Hello, welcome back to the Geography 300 for WVU, Geographical Data Analysis video series. This is the fifth of 6 videos for spatial autocorrelation. What we have seen thus far, I've presented within the context of polygon data, basically. So identifying the spatial weights for what polygons are neighbors to what other polygons, the implications of spatial autocorrelation, Moran's I, to test it. What we can do, though, if we have point data, is a different technique called a semivariogram. And what it does is basically we can actually have a little bit more information from our point data because we can assume ultimately it's not aggregated. The aggregation introduces some uncertainty within the distances. With point data, if I have an exact value, I have points here with numbers. If I have the value and the location, I can try to understand the exact structure or nature of that spatial autocorrelation. And that gets plotted out through something called a semivariogram. Semivariogram, it ends up being basically a very particular kind of scatter plot, at least as we started out. And each point, each dot in my scatter plot is not representing a point on the map. That is the first and probably in some ways the most critical and hardest thing to get your head around. Each point in a semivariogram scatter plot is not a point on the map. It refers to a pair of points. So if I am looking at 55 counties for West Virginia, or one observation per county, then I would have not 55 points here, but 55 times 54. If I have 100 points of observation, then I'm going to have 9,900 points in my scatter plot. So this ends up being a very busy scatter plot. So I have here a scatter plot with a huge number of points because it's doubled up. Every pair of points on the map gets a point in the scatter plot. And the semivariogram gets used for additional techniques which we'll not actually see in this course. Because of how it gets used, we typically have the vertical axis as the square root of the difference between the values at the 2 points, and the horizontal axis being the distance between those 2 points. Now if you notice, most, not all, because I have this 15 here, so here's a difference of 7 at a pretty close distance. But most of the time, if there are points close to each other, their values are pretty close to each other too. So that gets us most points down here in the scatter plot that is the semivariogram basis. As I get larger and larger distances, sometimes low differences can still happen. I've got a 3 over here and a couple of 3s over here. they're far apart from each other to have the same value. But when I'm looking at that distance, there could be values that are similar, but there could be values that are wildly different. And so larger differences show up more commonly at larger distances. Sometimes it can be pretty clear cut, and you can see a mostly empty area up here in the top left, where there are very few places that have a big difference but a short distance apart. If it is not that clear cut, what we can do, and what often happens in kind of behind the scenes at least, is to take different distance bands and draw ourselves basically we can think about it as putting in box plots for each of these distance bands. So we're starting to summarize this. Then we connect the medians. And we start to turn this into a function that starts out low, goes up to a certain point, and then basically flattens out. This distance at which it starts to flatten out is called the range. That is basically the range of the effect, the range of the autocorrelation. So if I tell you this is a 3, by the semivariogram you can tell, okay, places nearby are going to be similar to a 3, points nearby, but that kind of prediction ability gets weaker and weaker as I get farther out. When it flattens out here at the range, that's saying at that point there's no actual relationship between points at that distance and beyond. The amount of difference that we find there where it flattens out is called the sill. In many cases that's of less use than the range, but it may come up in things you see if you're using this kind of visualization technique for spatial autocorrelation of points. The last thing that you might see is if this red line, if this function of distance to difference does not actually hit 0 at 0 distance. That's called the Nugget Effect. What that means is if I have two samples that are extremely close to each other, effectively no distance apart, they are not guaranteed to be the same. The reason for this, and why it's called the Nugget Effect, comes from the origin of this technique that is from gold mining. And if you're digging a sample, a borehole, and you want to see how much gold is in that borehole to see if it's useful to put a gold mine there. So if you are right here and you hit a gold nugget, you have a pretty high value. If you go just a little bit over and you dig your borehole here and you miss that nugget, you now have a difference in the amount of gold there, the difference in the value at effectively zero distance, because you either hit or you missed that nugget, hence the nugget effect. Those are the three different main parts of the semivariogram. There are different functions that can be used, different shapes. Do you want this to be straight up and then come over, or more curved, or something that's kind of a vague S shape? There are different choices you can make there. Again, that different choice is in some ways not really part of the scope of this class. The main things to look for, and really this overall thing would be the same no matter what you picked probably. In the semivariogram, you want to look for some kind of upward slope up to a point, and or an area in the top left that is, even if it's not completely empty, an area in the top left representing short distance, big difference, that is less dense with points within that semivariogram. Either way you see this, you find there is evidence then of spatial autocorrelation in your individual point samples. That's where the semivariogram is, for here, is used for. As always, if you have questions, feel free to reach out, whether in class, office hours, email, please ask away. That has been seeing the different ways of measuring and understanding spatial autocorrelation. The last video of this particular topic will look at some of the conventions for presenting spatial autocorrelation in our reports. Thanks for watching. Have a good one.